Hello and welcome to this podcast from the BBC World Service. Please let us know what you think and tell other people about us on social media. Podcasts from the BBC World Service are supported by advertising.
Welcome to Health Check from the BBC World Service. I'm Claudia Hammond, and today I'm in Belfast at the Northern Ireland Science Festival because we have a special programme with a live audience on how children think. Here's a question for you.
This is Kevin and this is Peter. Here are some delicious donuts. Yesterday, Kevin ate a delicious donut. Tomorrow, Peter is going to eat a delicious donut. Who would you rather be? Kevin, who had a delicious donut yesterday, or Peter, who's going to eat a delicious donut tomorrow?
Now, the answer might seem easy to you, but it's not so easy if you're only 4 years old.
Yesterday.
Yesterday, so you would rather be Kevin. Why would you rather be Kevin?
Because I like eating donuts.
And that's because of the way our understanding of complex concepts like time develop as a young child. Now, have you ever wondered what a toddler is really thinking or why they find it harder to grasp some things than others? This is something psychologists have been studying, and today's show is all about the way children's thinking develops. And we're going to look in particular at their understanding of time and maths. How do they learn that 5 is different from 2 and that yesterday is very different from tomorrow? So with me on stage, I have 2 psychologists. We have Dr. Victoria Sims from Ulster University and Professor Teresa McCormack from Queen's University Belfast. And, of course, we have our lovely audience here. Now, Vic and Teresa, can I ask you, first of all, what got you interested in children's thinking? I'm imagining it's a field that can have its challenges. Vic?
So I suppose when I was at school, I was very into science, but I didn't really know what I wanted to do when I left school. And I took a gap year and I went to South Africa and I worked in a preschool. And in that preschool, I saw some children all of the children had come from quite adverse circumstances, but some of them were really excelling and some of them were struggling. And that kind of started to make me think about development. When I came back, I decided to take up a place in psychology at Queen's University in Belfast. And from that, I started to see that we could apply what I'd been doing at Science A level, constructing nice experiments. And we could do that not in the lab around biology and physics, but take that to look at child development. And that was really, really completely intriguing.
And Teresa, it must be quite challenging at times working with children. We heard a question there, but you've got to ask them the questions and try and keep them engaged and get them to, join in.
So I think that's really the bread and butter of a developmental psychologist's job. So if you're a good developmental psychologist, the main challenge that you have to face is really trying to find ways of working with children such that they're finding it accessible what it is that you're asking them to do, and you can be confident that they're not failing the task that you're asking them to do simply because they don't understand the language that you've used or because you've put too much emphasis on memory resources or attention that are required in order to pass the task. So part of what it is to train to be a developmental psychologist is actually to be able to overcome the challenges of working with children, particularly very young children who are still getting to grips with language.
So what's a good way of getting them to do it, Vic?
The handbag is always filled with lots of stickers, and children go out of the lab covered in little stickers or go out of the classroom covered in little stickers.
Stickers are your currency, I
Yes.
like that. Well, let's start by looking at maths first, which is your field, Vic. So do we know when children first start thinking about numbers? I mean, I guess early on they know that more of something, cake in particular, might be better than a little bit of cake.
Yes, so our knowledge around how children develop about mathematics is emerging really over the last 20 years. And there's quite a very strong suggestion that actually infants are born with the capabilities to be able to do some of those tasks that you just mentioned. So being able to do these kind of quantitative comparisons, what's more, object on the left or an object on the right. It's quite a controversial area of research. We've had a lot of controversy in terms of replication of studies, whether we can actually find these findings time and time again. But our current knowledge is around how this potential innate skill may be used to be able to develop a kind of more culturally appropriate set of skills, which would be about symbolic numbers and digits and number words and how those develop over time.
So what's symbolic numbers? Is that when that 5 means
yes,
5
so
fingers?
The digit 5 maps on to the quantity 5 and the number word 5, so that we can kind of tie together all of this information to make quite a complex system. And as adults probably take this for granted, as that we are able to say that when we see the digit 5, that represents 5 dots or 5 sweets. But this is a really, really sophisticated skill. And we can see that in children who are around 2.5 years old, they're starting to develop their clear understanding of what the number 1 and 2 means, and this takes a very long time. And then we start to see rapid development of what number words mean as they start to understand the number system. So it's a slow developmental pathway, but it's a really exciting one to be able to explore.
And are they learning it because they're explicitly taught it because parents keep saying to them, look, it's 2, 3, 4, and counting with them, or are they learning it some other way?
So actually some of our work has been recently looking at the home environment and how the home environment influences children's early number development. And what we do see is that in terms of more complex mathematical processing, so that kind of the stuff that we measure in school, some of that kind of formal instruction is quite important. But what we also see, and what's really important for parents, is this really informal environment is also essential for creating children's really rich representation of number and their confidence around playing with number. I think sometimes we think about mathematics as being something about arithmetic, so being able to add, subtract, multiply and divide. Mathematics is not about that. Mathematics is reasoning and being creative. So children who have the experiences of playing with quantities or playing with shape and space seem to do better in mathematics at a later stage. So being able to do lots of block play, for example, when you're 2, seems to be able to predict how well you'll do with mathematics at a much later time.
And you've recently done some new research on children's ability to place numbers on a number line. So being able to take, say, the numbers 1 to 10 and put them in order, spread out. Presumably what you're aiming for is equal distances there. But why is being able to do that such a milestone? What do children sometimes do?
So we have a very clear developmental trajectory in terms of how children think about how numbers are related to one another. Now, we recognise that numbers don't sit independently. They sit in a system. And what we see is when children are young, if we ask them to do that type of task, 0 to 10, where does the number 9 go? They seem to spread numbers out at the bottom of the number line and then squash them together at the top. They have this very strange representation of how numbers fit together. And with development, we see that children start to become more accurate. They spread the numbers out over the line. They have a linear representation. And what we see is children who are more accurate at that task seem to do better at mathematics. Now, why that relationship exists is something that we are currently exploring, because it doesn't just require you to be able to do that task. It doesn't just require you to know about numbers and how they fit together, but it also requires you to think about proportion, shape and space, all of these different skills, actually visual motor integration to be able to place the number on the number line. So actually we are looking and trying to explore why this relationship exists, and if it is a very important skill, can we train the number line task to be able to improve mathematics skills.
Now, we thought about getting some 4-year-olds on the stage and then asking them difficult questions to illustrate, but that seems a little bit mean, really. So instead, Vic, just the other day, you went to a nursery just outside Belfast to ask a group of 4-year-olds some questions, and we can hear you in action with them.
Now, William, remind me, I've forgotten. How old are you?
4.
4. Now, look at this. Here is a number line, okay? And look, there's no numbers on the line. But imagine 0 goes here at the left end and 10 goes up here on the right end, okay? Where do you think the number 9 would go? Right in the middle?
Yeah.
Okay. And where do you think the number 7 would go? Down in the bottom at the left-hand side. And we'll ask one last one. Where do you think the number 5 would go? Down at the bottom on the left-hand side. Good job. Well done, William. That was really good thinking. Well, first of all, Bradley, I know you're really good at thinking about numbers. How old are you?
4.
4. How old is your sister?
7.
How old is your mommy?
70.
70? What's the biggest number that you know?
The last number.
What's the last number?
509.
1,509? Wow, that's so big. Wow. Now, I'm going to show you some numbers, okay? And I want you to put them where you think they should go. Where would you put the number 8? Right in the middle, okay. Where would you put the number 9? Oh, right at the top of the number line. That's really good.
How did they do on those number lines?
So what we can see in children who are this age is that they're starting to become familiar with their numbers. So they're being exposed at home and in these children in a preschool setting to numbers. And actually these children were showing really lovely number skills. They were able to identify some digits and they were able to kind of show this, what we would describe as a fuzzy representation of how numbers are sitting. So they're showing exactly what we would expect and anticipate at this time. And what we're interested in as developmental psychologist is seeing how the development of this number system and how they understand about numbers fitting together within that system occurs over time.
And can parents help by deliberately doing things to do with numbers when the children are little, or do they have to have reached certain developmental milestones before they'll be able to understand those concepts?
I think that most parents will recognise that there are things that are just a little bit beyond their child's developmental point in time. And I think that there are many things that parents can do to help support early number development, but we have to keep remembering that number and mathematics is not just about number, and it's all of these really enriching play-based activities that parents can do that are really, really valuable. So we know that children who are exposed to things like playing with brilliant magnetic shapes or playing with shape and space in the home, this can be really, really valuable. But also doing things that are quite simple, asking your child to be able to set the table. That's what we call one-to-one correspondence, one fork with one knife and one cup, for example. These are things that are very subtle things that you can do in the home that can help aid early number development.
Now, I want to throw things open to the audience. There's one just here.
So with 3 young kids at home, I'm frantically thinking about how much to get the blocks out. But we're always doing art, and I'm thinking about how you place, where you put the pencil, how you bring in a piece of paper and stick it on the page, and how that might also help with grasping mathematical skills.
Vic?
Yes, totally. So I think that the really important thing to remember as a parent or as teachers is that there are so many important skills that we need to utilise to be able to be mathematically competent. So actually we see quite a lot of evidence that children's ability to be able to control their fine motor skills, so that exactly what you've described, being able to stick things down, being able to cut things out, are also related to mathematical achievement, because we're thinking about being able to map, for example, a number word to a set of quantities. We have to be able to maybe use our finger to point through that counting list. So actually doing those kind of play-based activities are also really important. And some research that we've done about children's just spontaneous interest in number in their environment. So getting them to describe a picture, for example, and watching what they describe in that environment. So they might be talking about colour, they might be talking about different objects. There are 2 butterflies, they're pink, and oh, look, the little girl's wearing a bow. And what we see is that some children do that a lot more, just very naturally, than other children. So sometimes when we're doing these kind of creative, artistic endeavours, we can also be pulling out the mathematical content within that environment. And that's really important, that we encourage children to be able to see that. But I also have to be careful, as someone who's obsessed with numbers, who's a number geek, that we also have to make sure that children are well-rounded.
Let's take another question.
I'm a maths tutor, and quite often I encounter children who just will not look at a number line. So these are older primary school children, and especially when it's fractions, placing fractions on a number line, they just, either there's something missing or they just don't want to do it. What should I be doing to help them along?
Good question. So I think that especially around fractions, number lines can be very, very helpful. And we know that children really struggle about ordering fractions because fractions are very, very complex. Sometimes in the classroom environment, we remove those visual representations or the manipulatives, so little building blocks, rods, things like that, at a time when we would see that as being appropriate to remove them. But actually some children who may be finding mathematics a little bit more difficult in the classroom could really benefit from holding on to those visual representations, those manipulatives, for just a little bit longer, and that will give them the confidence.
Well, thanks for the moment, Victoria. You're listening to Health Check on the BBC World Service. I'm Claudia Hammond, and today I'm in the Northern Irish city of Belfast for a special programme on how children think. So we've been talking about maths, but Teresa, your area of research is time and how we understand and perceive time. Does our understanding of time develop in parallel with, say, our understanding of maths, or is this a completely different skill altogether?
Well, I think it depends what you mean by understanding of time. So clearly, some of the systems that we use in order to talk about and represent time as adults are very mathematically based and require a lot of mathematical skills. If you think about the clock and calendar system, that's a highly complex system, and you couldn't really use it properly and flexibly unless you combined that system with your understanding of mathematics and number. But we know that children take a long time to actually get to grips with the calendar system properly. And indeed, children are still learning to use the clock and calendar system in a flexible way right up until the end of childhood. Indeed, there's even some evidence to suggest that adolescents are getting better at using the calendar system than older children. So that's one of the things that I'm very interested in my research. How can we try and unpick what the basic notions of time children possess in the preschool years? Now, one thing that we do know is that children, even newborn infants, are very good at being sensitive to the temporal properties of stimuli. So, for example, temporal patterning in speech, being able to distinguish between different speech sounds, being able to know when to expect to be fed, for example. Even infants are very good at picking up on those sorts of temporal information. But I think it's important to distinguish being sensitive to those temporal properties of the world and actually being able to think about time itself and being able to understand the distinction, for example, between past, present and future and what the significance of that distinction actually is. And I think that's the important and intriguing challenge for developmental psychologists.
So how does a child learn what the difference is between yesterday and next week? Is that just from constantly hearing adults say it?
We know that children, when they first acquire tense language, they tend to use tense language fairly accurately. So they tend to use the past tense appropriately for the past and the future tense appropriately for the future. But what's not clear is what they're using that tense to mark actually maps what adults and older children use that tense to mark. So one suggestion that's out there in the literature is that when children first start using tense language, what they're really talking about is something to do with properties of events. So those events are essentially that they use the past tense for are events that are completed, and those events that they use the future tense for are events that are not yet completed yet, are yet to come. Now, you might think, oh, well, that just does map on to an adult understanding.
That sounds correct, doesn't it?
Yeah, well, actually, as adults, we actually make this separation between the time at which events actually happen and the events themselves. So we have what I would refer to as an event-independent notion of time. So you can use a spatial analogy in order to explain that. So we can think about this space here independently of the objects that are in it. If we moved this table away right now, it would still be the same place. Okay? The same is true of time. We can think of points in time independently of the events that actually happen within those points in time. This is evident, for example, in our ability to realise that tomorrow, lots of different things could possibly happen tomorrow. So for adults, we make this distinction between events and the times at which those events happen. What's not clear is whether very young children are able to do that. And there's been a very interesting task that's been used recently to try to look at whether children, for example, understand the fact that there are multiple possible ways in which the future might turn out.
And let's have a listen to what some children think in action. When Vic went to visit the 4-year-olds, you gave her a question to ask them about time and the difference between the past and the future. We had a sneak preview of this at the start of the show, but let's have a listen to see what happened.
Do you like donuts, William?
Yeah.
I like donuts too. This is Kevin and this is Peter. Here are some delicious donuts. Yesterday, Kevin ate a delicious donut. Tomorrow, Peter is going to eat a delicious donut. Who would you rather be? Kevin, who had a delicious donut yesterday, or Peter, who's going to eat a delicious donut tomorrow?
Yesterday.
Yesterday, so you would rather be Kevin. Why would you rather be Kevin?
Because I like eating donuts.
Good job. Perfect. Well done, William. That's brilliant. You are how old, Esme?
4.
Yesterday, Emma went shopping and she bought a new toothbrush. Tomorrow, Jane is going to go shopping and buy a new toothbrush. I want to see a new toothbrush right now. Who should I ask, Emma or Jane? Emma, good job, Esme. Good job.
So it sounds as though some of the 4-year-olds understand what today and tomorrow mean. Others didn't. Is that what you'd expect at this kind of age?
So actually, the tasks there were looking at two slightly different things. So the task about the toothbrush, really looking at children's ability to understand what you might call the causal significance of something having happened in the past versus the future. If something has happened in the past, then there will be some kind of present evidence of that right now. So if somebody's got their toothbrush in the past, then you'll be able to see that toothbrush right now. If somebody's going to get it in the future, they won't. So the children actually got those questions correct. Okay, so those were 4-year-olds. If you ask 3-year-olds those questions, there's a very high chance that 3-year-olds would not be reliably correct. Going back to the example of the delicious donut, I think that's a very striking judgment that the child makes in that particular task. And that task is really looking at what you might think of the emotional significance of something being in the past versus the future. So there seems to be a really basic fact about human adult psychology that we prefer painful things to be in the past and over and done with, and pleasurable things to actually be in the future. And we actually couldn't really make sense of somebody who said that they'd prefer that a painful thing was going to be in the future, and similarly that pleasurable things were already over and done with. So what we were interested in is whether very young children shared the same intuitions about when they preferred pleasurable and painful events to actually occur. And what we found was 4-year-olds were just like adults. So if they were asked about a painful event, like getting a painful injection, they would say that they wanted that event to be in the past. But if you asked them about a pleasurable event, like eating a delicious donut, they also seem to judge that they wanted that event to be in the past. If we test children a little bit older than that, 6 to 7, they're already showing the adult-like patterns of performance. Now, it's very difficult to actually put your finger on exactly why the 4-year-olds give that response, but one possibility is that the 4-year-olds actually don't really have a notion yet of looking forward to something. The other possible reason that 4-year-olds might find that task difficult is that 4-year-olds find it very hard to wait. So some of the children, if you ask them why they want their delicious donuts to have been eaten yesterday, they'll say, "Oh, I don't want to have to wait for the donuts." So they find the experience of waiting in and itself so painful that they'd actually prefer to have their pleasures over and done with.
Oh, that's quite sweet. So in a way, they might be giving quite logical answers,
yes,
even though they don't seem quite like that to adults.
Yeah, I think that's exactly right. And we did collect explanations that children give in these sorts of tasks. And often children will just say things like, "Oh, I just because I like donuts." But that doesn't necessarily mean that behind that answer there isn't a chain of reasoning that's going on.
Thank you. Any other questions? Yes, there's somebody right up there near the back.
What recommendations do you have for a grandparent in terms of time? Can a child understand Santa will be coming, but it might be a couple of months?
So certainly by the time children are 4 or 5, they start to get some sort of grip on the distances of events in the future. Okay, below that age, they seem to have very little sense of the relative distances of events that are in the future. Now, if Christmas is just coming up and people are talking about Christmas a lot, then we know that that makes it salient in 4 and 5-year-olds' heads, probably closer to 5, and they can think of that as an event that's been due to happen very shortly.
And you've both worked with children with dyscalculia who particularly struggle with processing mathematical content. And Teresa, you've looked at how they might struggle to get things in the right order. What did you find there?
I think it can be tempting to think that children with dyscalculia just have problems with number, but there are all sorts of other more basic processes that are actually important when you're learning about number. So this was a study that we did comparing groups of children with dyscalculia with children who didn't have dyscalculia, and we gave them a number of different tasks that were looking at the ability to process order information. So, for example, one of the tasks involved reading a list of animal names to children, like cat, dog, cow, and so on, and then children had to tell you the order in which you'd said those words. Another of the tasks actually involved showing the children 3 sets of annual events, like Halloween, Valentine's Day in the summer, and they had to judge whether those events were in the correct order. And none of the specific tasks actually involved reference to number at all. So what that finding suggests is that those children might have more general difficulties in actual processing information about temporal order. And that makes sense within the context of mathematics. So if you think about what a number is a certain magnitude, it's a certain amount of stuff, as it were, but it also has a place within an ordered system. And getting to grips with maths involves getting to grips with the fact that it is a system that has temporal order built into it. And one reason why that's potentially interesting is that it potentially might provide us a way of thinking about how to actually help these children without necessarily directly working on their number skills.
Yeah, so do you think, Vic, that there are other things that are happening? They might be able to work on those other things instead?
I've worked with a group of children who we know struggle with mathematics, and that is children who are born very early, very premature children. Not all children who are born very early will struggle with mathematics, but as a group, they present as having difficulties. And there was a very strong idea that children who are born very early were actually dyscalculic, and this might be because of an underlying core issue with number. And we found through our research that actually their difficulties were being driven by difficulties that they had, kind of coming back to what Teresa said, with their working memory, being able to hold things in mind and manipulate them at the same time, but also difficulties with their visuospatial processing, so being able to map things together, to be able to do a complex arithmetic problem, being able to use that number line effectively. And this has kind of led us to thinking very cleverly, I think, and we think as a research team, about intervention for this group of children. Our kind of approach to intervention has been about talking to teachers, developing a really nice resource for teachers to understand what's going on in the premature brain, and thinking a little bit differently about how you might expose children to mathematical information and support their working memory and visuospatial skills in the classroom.
That's it for today's Health Check from Belfast in Northern Ireland. I'll be back at the same time next week with more stories from the world of health and well-being. Thank you to the producer Caroline Steele, and of course to our guests Victoria Sims and Teresa McCormack.
Goodbye to All This is a podcast about life and death. Above all, though, it's about love.
The family we've made is everything to him, and I am everything to him and he to me, even through those times we forget it.
It's about losing the thing you are most sure of, carrying on with the balancing act that is being human, rediscovering your place in the world.
Accepted wisdom in the dating world these days is that you'll never find anyone if you're not online. I accept one date. He tells me he's allergic to dairy, and all I can think to talk about is how much my dead husband loved cheese. We don't meet again.
From the BBC World Service, this is Sophie's story. But in many ways, it could be all of ours. You can hear all 12 episodes now. Just search for Goodbye to All This wherever you get your podcasts.